Hello, my friends, and welcome back to class. This week's topic, we are going to venture further out into space and learn about the universe as a whole. The universe at large is a very big place. And in fact, scientists, we are still trying to learn as much as we can about the universe, but it takes a long time to gather data and establish the hypotheses to better conceptualize or understand what exactly the universe truly is and what our role as humans play into it. But we are actually going to want to be able to mechanically describe the universe to our learners. You see, some scientists think that the universe is just a giant assemblage of all the suns and stars and other celestial bodies, with the Earth being part of it. Some scientists believe that it's a confined box floating into vast emptiness. But again, we really don't know. But we can also communicate that it's okay not to know in science to our learners. We're going to cover the vastness of space. This topic will allow us to pull information from our earlier units, such as the metric system that we covered in the first few weeks of the lab, and our current thinking in physics with the astronomy chapters throughout lecture. Because when we understand about the universe, the distance is less on the astronomical units, going from planet to planet to planet in relationship to Earth and the sun. We're actually going to be wanting to look more upon the light year, the distance between star to star. We're also going to understand and learn and then be able to explain to our learners that the universe has a dynamic entry. We're going to pull information such as the reactants and their products, and even earth science with deep time, and understand that, and also explain to our learners that it did not just appear suddenly, that there were actually events that caused and led up to what we call the Big Bang. You know, like in the TV show, it all starts with the Big Bang. Hey, that actually allows us to use that as a talking point. Or if you like to communicate to your learners about food, well, make some bread, raisin bread. You see, when you take the little raisins and you put it in the dough, you bake it. As the bread starts to expand, it mimics what physicists and astronomers actually believe that the universe will constantly being expanded upon, or the body of knowledge that we're always going to be gaining. It's just, again, is it more free flowing, or is it more of a confined box that just constantly stretches out? And then finally, are we alone? Are we truly alone in this universe? Maybe there is a general science class somewhere out in the universe that are asking the same questions you have acquired and wanted to know, and you've wondered about their topics. And so we're actually going to pull information not just from the astronomy and physics portion, but also human impacts. What are we doing as humans to be able to keep our planet sustainable and inviting in case maybe there's more life out there that wants to come and visit? Or how do we keep the planet sustainable long enough so that way we can develop the technology to venture even deeper into our universe? So really, this class has dramatically changed for the better. We have a set of learning outcomes. These were on the syllabus. And through the duration of the class, you have completed these different learning outcomes. You were able to interpret data for an outcome of an experiment. You can understand and explain the basic principles found within physical science, such as earth science, climate science, chemistry, physics, astronomy. And you can also be able to practice the scientific method and then implement it into your classroom. And think about it. When we go through these different topics, we also were building upon a new learning outcome. That's right. We all work together collaboratively to create and develop a toolbox that you can take into your classroom when the time comes and you want to go and teach a science class. And you can take this toolbox because it's going to be loaded with a bunch of different exercises and resources that you can implement into your science class. And these tools are actually built with the emphasis on the learner's perspective. How would your students attend your class and learn about science? In this class, we learned not just the different topics of science, but how do we approach these topics and be able to teach as teachers these topics. And that allows us to change our thinking, our perspective, and develop what they call interdisciplinary thought, bringing issues together of separate disciplines that are built around common themes, issues, or problems. For instance, when we learned about deep time, we were combining concepts found in earth science, but also natural science with understanding how life changes over time. And that can also be reflected in, say, chemistry. When we learned about some of the earliest life on land were actually plants, and put that into a time perspective. And this all occurs on the planet Earth, floating in space. Interdisciplinary instruction relies on multiple content ideas working to develop us and build upon your students' knowledge and generate creative problem-solving skills. And this will allow them to better connect their learning experience and build stronger self-confidence and be able to allow them to communicate what they are learning to you and others. And it also builds upon our sense-making, being able to relate our students to the material, but also implementing UDL principles by promoting the idea that students, they all learn different. They have diverse backgrounds and biases in which we need to be able to communicate these and understand how does the learner truly learn. And so you were able to do that through the last 15 weeks of this course. I've watched quite a few of you grow dramatically, leaps and bounds, going from, early education and even those that were just unsure of really what science is and how does it relate to your day-to-day lives. And then I watched you mature and grow exponentially and learn and change your way of thought, going from very concentrated into being able to accomplish linear approaches such as completing assignments to more applications of how does this topic relate to my region. You gain an appreciation of citizen science. And so now we can close the book on the class. And I've got to be point blank with you. I am very proud to being your instructor this semester. You guys not only learned new material and how to teach this material, but you also taught me as an instructor on how to be able to attack and bring out new bodies of knowledge. And we collaboratively work together to grow and promote science education in our Appalachian region. So again, you did really, really well. And for that, I will raise a toast and say, congratulations.